All right, so we're going to continue on with this. We're going to do questions 11 through 15 for this Algebra EOC. Okay, so here are some points on a line where the x value is this and the y value is that. If I kind of connected this dots, I would look like exponential decay. Okay, so remember that y equals a times b to the x, and b is plus or minus. When it's a minus, the r value is going to be b minus r when it's a decay. So b is going to be less than 1. Right? So remember that the a here is the y-intercept. Right, the a is the y-intercept, so it's going to start with 0.2. Right? 0.2 is our y-intercept, so that automatically gets rid of those two questions. Right? Now these are both decays. Right? So how do I figure out what b is? Right? So if I want to figure out what b is, I have to take this number divided by that number, and then this number divided by that number. And if they're the same, which they will be, it's an exponential decay. So 0.1, so 0.1 divided by 0.2, that's 1/2, or 0.5. If I see it here, 0.5 divided by 0.05 divided by 0.1, that's like 0.05 over 10. That's also 1/2. Right? So b value is 1/2. So b is 0.5. So b equals 1. This isn't right. This is 1 minus r. Okay? So b is 1 minus r. So b is going to be 1 minus 0.5, which is what I have right there. So that is my number 11. That's number 11. Okay, number 12. I have two binomial terms multiplied together. I can use the FOIL method. This is first, outer, inner, last. Right, so I'll do the first terms multiplied together. That's 5 times 7k is 35k. And then I'm going to do the outer terms multiplied together. 7k minus times -9 is going to be, oh wait, so that's right, okay. 7 times k, that's going to be -63k. This should be, this first term is 35k times k is k squared. Sorry about that. All right, so 7k times 5k is 35k squared. All right, so the k term comes from the outer and the inner multiplied together. So the outer is 7k minus 3, and then the inner is 5 times k, or 2 times 5k, which is going to be plus 10k, and then the outers and then the lasts are like that. All right, so it's going to be -9 times 2, which is -18. The only two terms I can combine are those two like terms right there. So 35k squared times or minus 53k minus 18 is my answer. That's one way to do it. And then we can do it with the Xbox way, right? Where I take one of the expressions and say 7k plus 2. Those are the two terms of the first expression. 7k plus 2. Separate them there. Multiply it by 5k minus 9, and then fill in the blocks. 5 times 7 is 35, k times k is k squared. 7 times 9 is 63, the k gets tacked on. 5 times 2 is 10, the k gets tacked on. And then -9 times +2 is -18. Those two can combine. This is a -63k, excuse me, sorry about that, because it's a -63k. Right, so this is going to be, those two are the combined like terms, which is -53k, that's 35k squared, and then it's going to be -18, which is the same as I got before. All right, so here is a function is shown, and which graph is this? This is in slope point slope form. So this is going to pass through, remember that this is x, this is y of 1, and this is x of 1, right? But it's negative, right? Because it's y minus y of 1 equals m times x minus x of 1, right? So these, positive 1, my y value is negative 1, and my x value is positive 3. So it has to go through positive 3 and negative 1, right? So where's positive 3 and where did I get positive? Oh, so this would be negative 3, negative 1, excuse me. Negative 3, negative 1. So it's got to go through negative 3, negative 1. There's negative 3, negative 1. This is negative 3, negative 1. There's the only one that's negative 3, negative 1. Okay. Another way to do this is to shift it to slope-intercept form. So variables left, constants right, but let's get rid of these parentheses first. All right, so y plus 1 equals 2x plus 6. I just distributed the 2 into the binomial. All right, so now do variables left, constants right. So, or actually, no, I'm doing y left, everything else to the right. So this is going to come over here. So y equals 2x minus plus 5, because it's going to be 6 minus 1. So it means it has a slope of positive 2. These all have positive slopes. And it's going to be a y-intercept of 5. So that was the only one that has a y-intercept of 5. So that's another reason why that is the correct answer. Number 14, Garrett buys some dog food, and he feeds 2 cups a day of dog food. Which type of function is that, right? So it's a constant change, right? Where this is the dog food in cups, and this is time, right? And this is in days, right? So it starts here, and then the dogs eat 2 cups per day. Remember that slope is your change in y over your change in x. Right, so this is your slope. It's 2 cups per 1 day. Right, so this is a linear equation, and it's going negative. It starts up here at my y value, and it's going to go negative. Right, so we'll say d sub x equals negative 2 cups per day. If I multiply it by day, all I have left is cups minus, we'll call this y value. This is the dog food total. Dog food total, right? So it's plus dog food total, because it's going to be plus. So it starts there, and every 2 days, or every whatever days, I take away 2 cups. And that's how much dog food I have at any given time t. Okay? That's how functions work. So this is negative linear. And then finally, I have this one here, where it gives me 4 function tables. And it's like, hey, which one is a quadratic function? Remember, for linear functions, your change in y is constant. For quadratic functions, this is linear. For quadratic, your change of y is constant, right? This is quadratic. And then for exponential, your change in y final divided by your change in y initial equals is constant. Okay, so let's see what we have here. My change in y for my change in x for all of these is 1, because this minus that is 1, this minus that is 1, this minus that is 1. It's 1 for all of these, and 1 for this one. Okay, my first delta, my first change in y, it goes this minus that is 6. This minus that is 18. This minus that is 54, I think. My calculator. Let me pause this and get my calculator out. Unpaused. So 81 minus 27, 54, right? So that my change in y is not the same. What about my change in y? Right, so 54 minus 18 is 36. 18 minus 6 is 12. So that's not consistent. But what if I do 54 divided by 18, that's 3. If I do 18 divided by 6, that's 3, right? So my change in final over my change in initial of y is consistent, so this is an exponential, okay? So let's look at this one, right? From here to here, my change was 1. From here to here, my change was 1. And from here to here, my change was, actually, no, it's 1, 1, and then 3. So 1, 1, and 3. Right? So now let's see the change in the change in. Okay? So this went from, wait a minute, that's negative 1. It went down 1. Right? So from here to here, my change in y, my double change in y is this minus this, which is 2. This minus this is 2. So my change in y is quadratic. So right here is my quadratic. This one, it changes by 2, right? That goes up, or minus, that goes down by 2. This goes down by 2 more. This goes down by 2 more. So my change in y is negative 2 divided by 1, negative 2 divided by 1, negative 2 divided by m is negative 2. Because it's a slope, this is linear. Right, this was exponential. This is a straight line. So no matter what value of x, y equals 7. That's what that is. So that's linear with a slope of 0. Okay? So anyway, that is how you do these ones. I hope that helped.